This is Mr. Ford. I will be doing the 7.4 special right triangles notes. So the goal for today is that I will understand the properties of special right triangles. So it's pretty easy today. There's two types of triangles that we're going to need to know today. The first one's called a 45, 45, 90 triangle. It says that the hypotenuse is the square root of 2 times as long as each leg. Check out the square below. So if I have a rectangle, right? And each leg is one inch, 1 foot, one elephant, whatever you want to call it, is just one. I know I have a right angle there, right? So this is 90 degrees, this angle here. Well, I know that since this leg is 1 and since this leg is 1, that these angles have to be the exact same. So if they're the exact same, and I know that a triangle is 180 degrees, and this one is 90, I know that both of these have to be 45 degrees. Okay, so now it gets really interesting. What if I cut the square in half, right? So I cut it in half. So now I have this length here. Well, I know from the last unit by the Pythagorean Theorem that a squared plus b squared is equal to c squared. So in this case, I have 1 squared plus 1 squared is equal to c squared. Right? And 1 squared is 1, 1 squared is 1, equals c squared. So I have 2 equals c squared, divide both sides, or not divide, but square root both sides to get c by itself. So I get c equals the square root of 2, right? So I get square root of 2. So that's just a little proof right here that the hypotenuse is square root of 2 times as long as each side, or each leg. So I say that 45, 45, 90 triangles are known as what? Isosceles triangles. So isosceles triangles, if you remember, means that 2 of my sides are the exact same. So just 2 of them, right? So this here, this side is different, but then I have this side and this side. So that is an isosceles triangle. I'm going to say that all, not some, all 45, 45, 90 triangles are similar. Okay, so then here's some shortcuts when solving missing sides in a 45, 45, 90 triangle. So I'm going to say the hypotenuse, like we said up there, is square root of 2 times as big as the legs, right? So I'm going to say that let's say L, wow, wrong tool there. We'll say L for leg times the square root of 2. I could have said x, I could have said whatever variable, but I'll just say leg, L, times the square root of 2. It's how I find my hypotenuse. Now I have to find, right, if I'm finding a leg, I'll say that the leg is the hypotenuse, right? H stands for hypotenuse, get it? Times the square root of 2, all divided by 2, because there's 2 legs. Right, so that is the shortcut for the leg there. So again, to find the hypotenuse, it's a leg times the square root of 2. To find the leg, it's the hypotenuse times the square root of 2 divided by 2. Right, so now we have to solve the missing sides. Okay, so in this triangle here, I know that this one is 8. And I know that my hypotenuse from up here is my leg times the square root of 2. So I know that this one is 8 times the square root of 2. Right? Now on this one here, the second one I have, now keep in mind these are all 45, 45, 90 triangles, so I'll draw my boxes ahead of time. So I know that this one, right, is 12, the hypotenuse. And I say that the legs are the half of the hypotenuse times the square root of 2. So in this case, half the hypotenuse is 6 times the square root of 2, right? And I just do that and fill it all in. Okay, then moving on. So now I have 9 as my hypotenuse. So I know that to find a leg, it's the hypotenuse divided by 2, all times the square root of 2. 9 square root of 2, all divided by 2. So there's that one. And then on this next one here, right, so I have my hypotenuse divided by 2, which is just 3, times the square root of 2. Right, and then I know that these are the same. Okay, now on to the next one. So this one's a little tricky. So I know that I have, 2 square roots of 2. So I know that this one is also 2 square roots of 2. But to find the hypotenuse, I take the leg times the square root of 2. So I know that my leg is 2 square roots of 2, but I have to say times the square root of 2. And if you guys remember from a couple sections ago, now I can multiply what's under here. Okay, and what's under there? 2's, so I can say 2 times the square root of 4, right? Which is just 4, because the square root of 4 turns into 2, and 2 times 2 is 4. Okay, so for the last one, I know that this leg is 7, so this leg also is 7, right? And it's 7 times the square root of 2 to find the hypotenuse, right? So there's that one. So those are 45, 45, 90 triangles. So not too bad. Okay, so now I have my second special triangle of the day called the 30, 60, 90 triangle, right? So it says the hypotenuse is twice as long as the shorter leg, and the longer leg is square root of 3 times as long as the shortest leg. So check out the triangle below. So I have this equilateral triangle. Let's use a different tool. Equilateral triangle. So my sides are the same, and my angles are the same, right? So now what if I were to divide this right down the middle? Okay, so now I have this, right? So that is this. Okay, so whenever I divide 60 into 2, this turns into 30. And I know that this is 90, so I know that my angles are 30, 60, 90. Okay? So to find this here, I have to do the Pythagorean Theorem. So I'll say 1 squared plus, let's call it x squared, is equal to 2 squared. So I say 1 plus x squared is equal to 4. So x squared is equal to 3. Get x by itself, and I get x equals the square root of 3. So I know that this side is the square root of 3. All right, so from up here, we know that the longest leg is square root of 3 times bigger than the shortest leg. And the hypotenuse is 2 times as big as the shortest leg. So that fits there. So I said that all 30, 60, 90 triangles are known as what? Scalene triangles. So all 30, 60, 90 triangles are similar. And again, similar means that the angles are the exact same, right? So the lengths of the sides can be different, but I just know that the angles have to be the same. So the shortest leg, right, to find the shortest leg, I say that is half of the hypotenuse. So I could write that as 1/2 times h. And we could say that's SL, shortest leg. Okay, so then to find the longest leg, right, I say, well, that's half of the hypotenuse, all times the square root of 3. Right? And my hypotenuse is just double the shortest leg. So I can write this as longest leg equals half of the hypotenuse times the square root of 3. And I could write this as my hypotenuse equals 2 times the shortest leg. So those are some of the examples or some of the shortcuts to find this. So now let's go to the examples for the 30, 60, 90 triangle. So this says, if I have a triangle that has a length of 16 for the hypotenuse, right, I know that my shortest leg, right, is going to be half of my hypotenuse. So in this case, I know it's just 8. Okay, and I know my longest leg is half as big as the hypotenuse times the square root of 3. And I already told you that half the hypotenuse was 8, so I know that this is just 8 times the square root of 3. Right, so that's not too bad. So keep moving here. So straight across, I know that this right here, that's going to be my longest leg. Okay? So I know that my hypotenuse is twice as big as my shortest leg. I know that my shortest leg is half of the hypotenuse, right? So if I go back up to here, I know that my longest leg is half of the hypotenuse times the square root of 3. Okay, so we don't know the hypotenuse yet. So how can we find this? So the hypotenuse is double the shortest leg. Well, we don't have the shortest leg either, right? So all we have is the longest leg, right? So we can't do anything else with this. But we are going to know that my shortest leg here is going to be, so shortest leg is going to be equal to 8 over the square root of 3. So I'll multiply the top and the bottom by the square root of 3. So I know that's equal to 8 square root of 3 over 3. Okay, so I'll write that. So I'll write 8 square root of 3 over 3. And I know that my hypotenuse is twice as big as that. So I'll say my hypotenuse is 16 times the square root of 3 over 3. So now moving on. If my shortest leg is 7, I know that my hypotenuse has to be double that, so it's 14. And I know that my longest leg is my shortest leg times the square root of 3. So that one's not too bad. On my next one, I know my hypotenuse is 10. So my shortest leg has to be half of that. So I know my shortest leg is 5. I know my longest leg is the shortest leg times the square root of 3. So again, it's just following the formula. So I know that if my longest leg is 12, right? I know that my shortest leg, so this one down here, shortest leg, is going to equal 12 divided by the square root of 3 times, I'll get the radical out of the bottom, times the square root of 3 over the square root of 3. Okay, so that is equal to 12 square roots of 3 divided by 3. But we could just say that's the same thing as 4 square roots of 3. Right? So I know that because of that, my hypotenuse is double it. So I'll just say 8 square roots of 3. Now we should be able to knock this one right out of the park. So I know that my shortest leg is 1. So my hypotenuse is 2. I know my longest leg is the shortest leg times the square root of 3. So this is just the square root of 3. So anyways, that is all the notes today. So again, it's 45, 45, 90 triangles and 30, 60, 90 triangles. Thank you for listening.